So we are working with the industry, with our customers, and with the regulators to put this standard out for everybody. There's no exclusivity in that, and it's in our best interest that it's copied. Everybody built on it. For now, our customers trust us because they see that we have a framework and they see the results from our work. We are planning to build our own eval LLMs, right? So think quality LLM, and this quality LLM has two jobs. One is understanding what are the metrics that are used everywhere, right? We have millions of test runs are running every month on wide set of applications. Even within LLM, there's a wide set of applications of that.
Hi, I'm Craig Smith, and this is Eye on AI. In this episode, I speak with Mohamed Elgendy, CEO and co-founder of Kolena, an AI quality platform that helps teams test, validate, and ensure their AI products perform as expected. Mohamed shares his insights on the challenges of testing machine learning systems, the importance of having a systematic framework for AI quality assurance, and how Kolena is working to define a gold standard for AI evaluation. We discuss the role of human evaluation, the potential of using adversarial models for testing, and the future of AI quality standards. Kolena and the MLOps community are joining forces to host the inaugural AI Quality Conference, or AIQCon, the first conference in the industry to focus on advancing new standards and best practices for AI model testing and quality. Taking place on June 25th at the Hibernia in San Francisco, AIQCon will bring together leaders from Cruise, NVIDIA, Google AI, Anthropic, U.com, and many more, as well as top VCs and journalists, to discuss how the industry can consistently build high-quality AI systems, prevent model failures, eliminate biases, and drive greater adoption. I hope you find the conversation as interesting as I did. Hi. Good tech solves problems that you thought about. Great tech solves problems that you haven't even thought of. What can the commerce platform trusted by millions of merchants do for you? It's time for Shopify, the commerce platform revolutionizing millions of businesses worldwide. Whether you're a garage entrepreneur or IPO ready, Shopify is the only tool you need to start, run, and grow your business without the struggle. Shopify puts you in control of every sales channel, so whether you're selling satin sheets from Shopify's in-person point-of-sale system or offering organic olive oil on Shopify's all-in-one e-commerce platform, you're covered. Shopify powers 10% of all e-commerce in the United States, and Shopify's truly a global force, powering Allbirds, Rothy's, and Brooklinen, and millions of other entrepreneurs of every size across over 170 countries. Plus, Shopify's award-winning help is there to support your success every step of the way. So sign up for a $1 a month trial period at shopify.com/eyeonai. That's Shopify, shopify.com/EyeOnAI, that's EYEONAI, all lowercase, all run together. Go to shopify.com/EyeOnAI to take your business to the next level today. Give them a try. They support us, so let's support them. AI might be the most important new computer technology ever. It's storming every industry, and literally billions of dollars are being invested. So buckle up. The problem is that AI needs a lot of speed and processing power. So how do you compete without costs spiraling out of control? It's time to upgrade to the next generation of the cloud, Oracle Cloud Infrastructure, or OCI. OCI is a single platform for your infrastructure, database, application development, and AI needs. OCI has 4 to 8 times the bandwidth of other clouds, offers one consistent price instead of variable regional pricing, and of course, nobody does data better than Oracle. So now you can train your AI models at twice the speed and less than half the cost of other clouds. If you want to do more and spend less, like Uber, 8x8, and Databricks Mosaic, Take a free test drive of OCI at oracle.com/eye on AI. That's EYEONAI, all run together. Oracle.com/eye on AI. That's oracle.com/eye on AI.
Well, thanks, Greg, for having me. A bit of background. I'm Mohamed, CEO and co-founder of Kolena. Before Kolena, so I'm a technical founder. Before Kolena, I was in machine learning leadership roles for a big part of my career. Worked at led AI teams at companies like Amazon, Twilio, Rakuten. Worked on different set of machine learning problems. Before that, I was a software engineer, and my education was in biomedical engineering, so software and hardware engineering in the healthcare field.
Okay. Yeah, tell us about Kolena. How did you come to start it, and what does Kolena do?
Yeah, so things started with us when, Kolena is an AI quality platform. It takes care of the testing and validation and ensures that the team is building a product, an AI product, that they know exactly how it's going to perform, and they have tested it rigorously in a systematic way. Things started with us before that when we, like a few years ago, many years ago, we were working on building AI systems. We started noticing that every time I work with a team, we have to build some kind of solution for testing. The reason here is machine learning is not a deterministic process or not a deterministic product. These algorithms, they define the logic as opposed to engineers defining the logic in software. So that ends up making the testing process very tedious and time-consuming. And more importantly, it's an ad hoc process that heavily relies on the scientists' intuition and their experience in machine learning and experience in the domain and in the company, because they need to remember, we failed in these areas last year, we failed in these areas this year, so I need to look into that. The nature of this process being, not a systematic process and a very ad hoc process, leads to a lot of blind spots in the test, leads to misalignment between teams. And then the end product is something that nobody knows, whether the scientist that's building the product team that is actually speccing the product or the user. Nobody knows really how it's going to perform in all scenarios, which led to the term that's known as long tail edge cases. Now, this is compounded now by the generative models that started now, where it's trying to achieve, more of a generic purpose that makes it really, really hard to start relying on the scientist's intuition. It was already hard before, and now it's becoming impossible. And we're seeing in the industry how things are going we'll probably talk about it if you bring it up, but with all these models and how things are going. So with that said, we started with looking into how we've been building models, whether it's language models, vision models, structured data or time series like recommender systems and structured data side. We started seeing that, okay, there's a need heavily for us as builders to have a framework. First of all, not even toolings or anything. What is that framework for testing? This happened in software, which is machine learning is software. So it happened in software when it was very early beginnings, let's say 3 decades ago or more. In the early beginning of software, everything was still manual and ad hoc and still not reliable even at the end, until the software community started thinking about quality assurance processes and frameworks and started thinking about, okay, we need to have some unit tests and functional tests and user acceptance tests. Like now we have stages and everybody understands. So when you talk to people, any stakeholders working in software, it's clear what stage is your software, and we're in beta. So we launched, but still in beta, and we're expecting what happens there. That's not the case for AI. It's still, we don't know really. The biggest question we hear from customers or practitioners in space, it's not like what's your tool doing? It's more of the first question is, how do we do it? What is that framework? So we're focusing first on defining that framework. Now, comes after the framework is the tooling process or the infrastructure that automates that framework. So there are 2 stages in our head that we're working on in Kolena. One is defining that quality framework, and then defining this gold standard of what quality means. What is pass or fail criteria look like? What are you testing here? If you're testing a computer vision model, you need to be testing, let's say it's an autonomous vehicle in a perception context. You are testing whether the vehicle or the sensors or the algorithm is able to identify these obstacles or objects. And now you want to test how it's doing for different scenarios, right? Like occlusion, not occluded, day, night, rain, snow, and so on. And now you have defined what's called the test coverage. This is what it's called in software. So when Mohammed and Craig are working on building their product, you see Mohammed is an engineer, Craig is a product manager, for example, and we work together and define what these functional requirements should look like as best as we could. And now they are defined. Everybody in the team you start having these alignment and trust with everybody in the team. We understand what we're building, so you build to specs for the first time in machine learning. So that's the example in autonomous vehicles. And then you add another layer. How are you testing this? Not just the test coverage. What are the metrics? Is it the traditional metrics that we know about in machine learning, like precision, recall, accuracy, F1, and so on? Or for this specific application, which in this example, it's autonomous vehicles, then do we need specific metrics? We call this product level metrics. You'll not necessarily want to test if you rely on recall, which is looking at false negatives. You don't necessarily want to test at this level at the recall metric, which is how many objects you have missed or the model has missed. But a more effective metric which is a product level metric. You want to call it collision risk, because that's the goal. And then collision risk is not just missing the object. It is how it's a function of depth to how far this object is. This way, if you're looking at the collision risk as opposed to recall, which is looking at the missed objects, you start seeing that this model A or system A is really good at identifying objects when they are in the collision zone, right? And then another one is which has better score for recall, but it's really poor at collision risk. So that's the example here, and that same thing for question answering for LLMs. If you use the traditional language models, metrics like Blue and Rouge and others, versus a custom metric, if it's an Q&A application, then correct answers to test factualness. So it's a function of BERT and Blue and others, and maybe a threshold that you want to set in there. That's what we call a gold standard, which is defining the test coverage. Part of it is some scenarios, some part of it is data leak, part of it is hallucinations and others, and jailbreak and so on. So identify the risk, which NIST calls this risk management framework. So you map, this is the first function, you map these risks or the functions that you want. And then the second step is identifying what metrics you're going to use to test each of these functions. And then the third thing is, what is the pass or fail criteria? So this is what we call a framework to test. Once this is defined in the industry and inside the organization, now everything becomes a systematic and the process, and then you start evolving the process to more areas and evolving the framework.
The models that you're evaluating or testing are they proprietary models built from scratch, or are most of your customers fine-tuning open source models or some instance of a proprietary model? I mean, what or are you being used by Google and OpenAI to test the foundation models that they're building? Where in that market are you guys?
Yeah, we are. We support, we built Kolena to support the three layers that you mentioned. The teams that is building their own generative models, whether it's language or vision now, and then teams that are using these language models to fine tune into the application, because there's a layer here that you need to find the best of these tools for your own application. So you cannot just rely on these benchmarks on the internet. You need to test it on your own data. And then the third one is these foundation model providers. We don't work with OpenAI and Google specifically, but we work with the other two layers. And some of them are building their own foundation models for their own applications, or they are tuning these applications. But the step before tuning is, what is the best one to start with? Because there are strengths and weaknesses that different for that. So you want to test it on your own, figure out which is the best out of the 10s that are available now, and then guide the fine-tuning process. Because fine-tuning process here, you want to send data to the provider and here retrain on this data. So you need to understand where the weaknesses are. And we'll dive deeper into this when we dive into our framework. But we serve these two layers as of now, and we support all the layers.
Yeah, and when you talk about coverage, it's not like unit testing where you have a code base and you need to cover a certain percentage of that code base with unit tests. In what do you mean by coverage in this context?
Yeah, that's a good question. We've been going back and forth on what is the term, because you mentioned unit test. We call it unit test. We understand the confusion here that might cause unit test in software. You're talking about the code coverage, so you're testing the code. Unit test we mean here on the machine learning side, scenario level testing. You are not looking at that aggregate metric. You wouldn't say Llama versus GPT-4, Llama 2 versus GPT-4, 90, 92, or 93. That is what's done now, which is the aggregate metric. Unit testing is looking at every scenario. How is this model doing for hallucinations? And then you break hallucination down into these stages. And how is this model doing for jailbreak? How is this doing for data leak? Because data leak here is defined even, like, for example, differently, or even bias. So bias can be gender bias, can be race bias, can be just bias for, if it's in a healthcare application, we have one of our customers building their own Gen AI for that. So bias here, you can be biased towards a department in the system versus another. So bias here will be defined based on the application. So this is usually what goes with that.
Yeah. And how do you do that? I mean, I was just talking to somebody about whether or not large language models will develop a true understanding of the world. And what they were saying, which was interesting, this researcher, is they probably will, but we'll never know for sure, because you can ask it a bunch of questions and it can give answers that demonstrate understanding, but you don't know if you've asked the right questions. If you ask 5 more questions, it may break down, and so you're never going to have a certainty. So how do you deal with that? I mean, you can, in scenario testing, you can come up with a dozen scenarios and test them, but there may be a 13th scenario that you didn't test in which the model breaks down.
Yeah, so I read your article on Forbes last week about the understanding, and I totally agree with his thoughts, because we need to define what's understanding first before we say whether these models would understand. From the perspective of, so what these large models do, or in general deep learnings do, they start painting or drawing this mind map, if you will, if you try to visualize it. And if you have an object like a car, it knows that it takes, when it's training, it takes, okay, a car is an entity. It doesn't know what a car is, but it's an entity, and it falls in under the vehicles, types of vehicles, and falls under like a means of transportation. And then within vehicles, you break it down into cars, trucks, buses, and others. And then within cars itself, you start adding characteristics of cars, what do they look like, 4 wheels, and so on. And then you start adding how to drive. And then from that context, it understands, right? Maybe, probably, definitely, it recalls more information. So from the information perspective, more than a human, because it within this entity, all types of cars out there, better in specific areas, and how it aspects of the car. So from that perspective, they do understand, and they will understand or recall information, or put the map of information about these entities better than a human. Now, whether they understand is something that we need to define, like exactly like general intelligence. What is that? So we need to define what this is from the perspective of a data scientist building a product or testing a product. It should be the same. Like the idea of how much it understands that this is a car, how much it understands and predicts the next token or the next word. From us, we want to understand based on the product. And we work with our customers, instead of going ahead and say, okay, here's a model or here's an algorithm, then we test it. That is a very big task. Nobody, like QA is not something that software just started. Right? Every product we have has some QA process, like it doesn't go out to consumers this way. So with that, you need to define the specs first. Like, this is what quality is, built to specs. You cannot say this $1 pen is higher quality than $100 pen, because it's built for that purpose. So it is high quality. So the way we approach that is we work with customers and start saying, let's build to specs. You are building we have a customer that's doing like really, really exciting work, automating the drive-through process. You go in and you give your order, and then actually several of those, because it's a very hot area. Now, if you start, and they are in the applications is based on what you asked before. They are testing these LLMs and finding the best, and then fine tuning internally and through the provider. So when you start thinking about this, you can't just, how are you going to test it? Because you need to collect data for this kind of test or prompt it and you see results. So you need to think about first, okay, how much is it able to extract the order that I'm ordering? And how much does it understand confusion here? Because if you are give me a burger, you don't want it to be confused by something that's outside the menu, right? Like a burglar, right? Like that doesn't make sense. It should be able to map that somebody said the burger and map it to the menu, right? Now that menu, this process is called RAG, which is the retrieval augmented generation. So you want to build first to specs. You define, okay, I want to be able to extract what the order is. I want to be able to handle corrections when somebody or handle the customer changing their mind. So now you start building the specs. Now with these specs, and then you want to handle angry customer. So that's another spec. So with that said, you will build your product, your first version, based on these specs, and then you will throw it out to your customers and handle the risks, obviously the biggest risks that you worried about, and then give it out to customers. And then it's an iterative process. It becomes the monitoring piece, which our quality solution involves three main pieces: the data quality for training, and then pre-deployment test, and then post-deployment evaluation and monitoring. And then so the shortest answer that I'll give you is it's an iterative process that starts with, like any product and like any software specifically, it starts with defining the risks and functional requirements, build the metrics and test coverage for that, and then start testing. And then now you are systematically chasing that long tail, and you're not relying on data scientists in the company with their own experience, and if they leave and come back and their memory, this whole thing becomes a systematic framework.
Right. And how much are humans involved in this? How automated is this?
So there are several stages. We automated the biggest parts of most of them. So our first part is the data quality, understanding the quality of your test data. Some known properties of quality of data, like missing values or inconsistent values and so on. So you clean up, you make sure that you have high fidelity tests. So you want to make sure, okay, my test is this way. And then within that, the functional requirements that you have just defined, there is the area of identifying blind spots. So the long tail of edge cases here, you have a customer that's been working on a problem for a couple of years. So they have a long list of these functional requirements because they have the experience. Now you have another customer that just started today, or you have another machine learning team that just started today. You have a much smaller backlog of this and much smaller knowledge of the system. So the way we automate this is we are looking into these applications domain by domain and building a library. It's think of it as a recommender system, a library of all what we can see as known now across the industry, not known for your own company alone. All the known edge cases across the industry, and it comes as a recommendation system. So you are building, again, this drive-through application, automation application, and then you will have defined 20 of those, and you find Kolena recommending another 40 or 50, and mapping them to your data. Example of this, like you're looking at it, like I said, an angry customer, and defining an angry customer as how to handle that. So you want to, another customer didn't think of this, so we wrap this and we tell them within your data, you have 100,000 prompts, let's say, for example. We saw that there's 15,000 prompts that are representative of this angry customer. We group them for them and tell them, take that or not, and then you can ignore it if this doesn't apply to the application. So that's the data quality part. Make sure that you have covered as much as the industry collectively has known about these unknowns to speed up this product evolution. And then identifying blind spots and creating these test cases. The second, then they train, if they train internally, like OpenAI or others, or they are fine tuning. and then which is outside Kolena, training and everything is outside Kolena, and then the test on Kolena. So the first component, data quality, we talked about it, and then the testing part here, you start defining what are the test coverage, the test cases and test coverage, we just talked about that. And then what are the metrics here for each one? Now, these metrics here, matrices, this is where we get into a fusion between automated matrices and human eval. So, example of human eval, we all use several tools like the GPT tools, type of not GPT tool, like question answering tools, if you will, right? So ChatGPT and others. And then we have our preferences. So like, you know what, this tool always answers better to me. Just it's a situation. This other tool talks more and doesn't follow prompt, for example. So that is more subjective. And so some test cases or some testing scenarios will require human eval. Now that human eval here, we built a framework for this, and then you're able to define the questions that you want to ask Craig and your users or your internal testers. And then they go these lists of results for the models, and one or more, and then give some eval. The system learns that you are looking for data leak, and the data leak here, you don't want the person's name or the person's age to be retrieved if you're reading from your HR system folder, if anything. So having defined the metrics, and big part of the metrics can be automated. Another part of the metrics has to be a human eval, but it's been defined now. And then the third thing is defining pass or fail criteria, which is the last thing here. Pass or fail criteria here, it's impossible for a non-deterministic system like machine learning models in general to tell it, okay, when you reach 90%, automatically deploy. Or when you reach 99%, you cannot say that because there's no 100%. So now with that said, there are different ways that you want to define pass or fail criteria to get the full automation of that evaluation. So several approaches that we have is you define critical scenarios or test cases, and then you say, okay, then for any models that I'm updating now, pass or give it pass or success when it's not regressing on these critical scenarios. We can never deploy without any regressions on these scenarios. Now, that kind of automation allows us in the training, which is outside our product, outside Kolena, allows us to throw out 50, 100 or so experiments, push them all together in training, and then automatically when the model converges, when like the training and validation set started to agree on the results, then you go ahead and run a test on Kolena. And instead of looking at these hundreds of models, how they're doing, you're looking at only the 5 or 10 that did not fail in your pass or fail criteria or did not regress in your critical cases. Now, this automation allows faster iteration in training and faster validation process.
Right. On the human evaluation, you say you have a framework, and then do you plug into some sort of a crowd sourcing platform like Mechanical Turk? I mean, where do you get your human evaluators?
Yeah, so that's the plan. As of now, we have been, the last 2 years, we've been working with select customers. So we're actually about to announce something next week. Will be more open, but for now, our customers are AI first companies, and they have their sources, and they want to evaluate their models with by specialized people in the domain, like we in the healthcare domain and so on. So with that, for now, our customers are taking care of this quote unquote labeling, but it's actually evaluation, human eval. Now, soon enough, when we're planning probably sometime in May or around May Q2 timeframe, we will start providing these, whether plug it into mTurk from AWS or others, plug it into this human evaluators for other cases, and then applications that are in production that like you have like ChatGPT as an example. Now we can utilize this massive user base that they have, and then build in the feedback based on the customer's response to the prompt, or they give feedback, but it's much more better feedback than thumbs up and thumbs down.
Right. And on the automatic side, is each evaluation strategy unique I mean, or do you have templates at work? A customer comes in, they have a particular problem, and you have uh, an evaluation protocol that off the shelf that will apply to that, or do you have to craft a new evaluation strategy for each customer? How general can these solutions be?
Yeah, so it's a hybrid of a automated template. It's not really a template. I will explain it a little bit more now, and configurable by the customer to add their own metrics. So the example of that is, let's say we have a text summarization problem, asking ChatGPT to summarize news articles or something. Now, every the data scientist will think about the category of the articles and like if it's sports versus technology or others, maybe the level of the language that's been written. Like they will think about their product perspective. But what Kolena knows is there are properties for a text summarization problem. So we generalize by the type of the problem. So text summarization here, there are properties that affects the sensitivity of the models, and it's impossible to be determined by just a human data scientist eyes or something like the length of the article. Right? This is it looks simple, but it heavily affects the summarization process. And now we present that as a recommendation to our customers when they come in. They see the length of the article, the language, the attitude, and so on, and the sentiment, and then they see that, and they see the distribution of their test data on that metric or that property. Now they start you start seeing, okay, all for text for length of the article, for example. Then you start seeing, oh, all my data are shorter articles. I have a blind spot in larger articles. This is when they start knowing that. So when they come in with their own properties that they know about for their own problems, Kolena provides the unknowns that are always feeling that are common for your specific problem. So that is for text summarization. Another very obvious one that it took us a few months to debug when we were in a previous product we were building is in object detection, the bounding box. Now, we are always looking at, okay, the bounding box, let's say if you're doing face recognition, and it's my face and your face here. So that bounding box, we just look at, okay, are the features, if the model failed in Mohamed's, face, then are the features clear or not? Are okay, the lighting, the contrast, the noise? So, and that's valid. But what we don't see is the aspect ratio of that bounding box. It's one of the main reasons these models fail. Now, aspect ratio here can represent depth. So if my face is here and my face is right there, then you start seeing the aspect ratio goes heavier. And now if your model hasn't, even though the features are clear, that eyes, nose, and so on, but the model will fail, there's a chance it might fail in this area if it hasn't been trained in that size. That's the interesting part about neural networks. They are very powerful, but they're not very intelligent really, because they get confused by these nuances. So that's the bounding box. And then obviously the number of bounding boxes, if you have 10 people on the frame there, all the features are clear, but that affects the model sensitivity versus 2 or 3 people. Now, these nuances this is what our R&D team is always working and understanding these reasons of failures across different domains, and they come out of the box as a recommendation for our customers when they look at, okay, my problem is a bounding box problem, is a text summarization problem, question answering problem. They start seeing the data analyzed on that scale, on these properties that we have defined, and then create test cases based on that.
There have been some really high profile failures of evaluation. The most obvious one is Gemini. With its image generation. What do you think went wrong there? Because that, to me, it just seemed like such an obvious problem. It's hard to believe that they didn't catch it.
Yeah, it's actually the answer is in the given, because I read something maybe yesterday. Sergey Brin mentioned that we needed much more testing of the models, and then I read the official statement by Google, and it makes sense. The intention is clear, is good, and which is making, hey, we are optimizing for reducing bias, right? But now optimizing for reducing bias means here they went so far, which ended up being a different kind of bias. That's what people should know. Now, that is NIST has published this risk management framework probably 14, 15 months ago. And it aligns very well with our framework that you need to identify the risks first. Now, when you identify the risk, that we say, we call the build to specs. So if you build to specs and say, I want to build against bias, racial bias, which is the example that we're referring to for Gemini, then we want to test against what's the pass or fail criteria, right? And then and this is one of the things that we provide at Kolena, recommendations of you have to provide positive and negative examples. So that's the framework, right? So positive and negative examples. So if you, let's say, if Gemini was using Kolena, they will put in the models and you put in, bias. And then we notice that, hey, your racial bias data set doesn't have negative examples, right? You're testing that, give you 10 people of different races, but have you tested the negative example of this, which is, again, part of that framework of how to construct that high fidelity test case. So, and then again, after that, pass and fail criteria and metrics for this. So I'm not familiar, I don't work with the Google or the Gemini team specifically, and I'm not familiar with the internal testing process, but my best guess is, it has been done with the way that it's done in the industry now, where it's like a group of brilliant engineers recalling previous failures from their head or writing down in some internal wiki, and manually testing that, which is very, very prone to human errors because you're relying on their own effort in identifying these requirements, constructing the high fidelity test cases, defining the metrics, and actually doing the job of evaluating that.
Isn't there a way to have sort of an adversarial LLM, not necessarily an LLM, but large model, in the way that AlphaGo learned to play chess by playing against itself? You could have, another, and I know that there's research into reinforcement learning with AI feedback. Do you guys do any of that? So you train a model to, ask questions or generate prompts, and then the model itself can evaluate how well or poorly the model that you're evaluating does.
Yeah, so this is a practice that started gaining popularity in the last few months. We've seen it working very well in cases, and others are not. So, to take a step back, any approach that we are recommending or we're putting as a feature on Kolena or as a framework in general, we take very high responsibility on that, and we do a lot of homework before we actually push it out, because we are a platform of trust, right? So we have to actually, if our customers look at the results and trust that. So the approach is, this all relies, after you have defined the framework, how you're going to validate your models against these metrics that you define. Now, this is a hybrid of, like I mentioned, of automated matrices, metrics, and human. I said if using that with human evals. And then the third thing is, so to be one of each, is using LMs. LMs are really good, especially when they are trained for that purpose, are really good in identifying which paragraph, if you again still summarizing paragraphs, which paragraph is more succinct in defining the area, which one is more talkative. You can be building for each. If you like, Grok is building to be a woke kind of platform, or a cool responses or something. So again, once you have defined the metrics that you're going to use to evaluate, now for each metric, here becomes the diversity of things, because the metrics are different. We are, as of today, we're supporting automated metrics, and we are recommending these metrics for others, and covers a large part of the risks, especially because that's the highest area. So we're focusing a lot on these automated metrics and the human eval workflow. Now, LMs, what we're planning to do, as we tested that on current LMs, we saw a lot of gaps there, and because they're not built for that purpose. But we are planning to build our own eval LLMs, right? So think quality LLM. And this quality LLM has two jobs. One is understanding what are the metrics that are used everywhere, right? We have millions of test runs are running every month on wide set of applications. Even within LLM, there's still a wide set of applications of that. Then we are the best positioned to understand what these metrics are and how effective they are and how they are defined for pass or fail criteria. We train our own LLMs think of it as a manual federated learning. We don't really have a system because customers' data cannot see each other, and it's obviously the whole privacy part. But we're able to understand what are the common metrics for these specific problems, and then build models to automate that. Now, that's step number one. Step number two is adding reinforcement learning, so it becomes specific to a customer. When they are, let's say Craig is working today on a problem, and then you added a metric, and in the middle of the problem, you add a metric that say how good the model is in following prompts, right? Now, that following prompts is a metric that can be generalized to all your question answering. Now, but you want it here for you just added it today. It learns by the votes that your customers are given, or it learns by the way that you're testing, however you're doing it, and then it goes ahead and re-evaluates the rest. So instead of you going through millions of data points, you give the first 1,000 or 2 or however the ratio look like, which is an approach that has been known in labeling before as active learning. But this is again different applications of that is being able to take the feedback from the customer evaluation live and then recommends the evaluation for the rest of your data.
And so you're building an LLM that will do that. When are you likely to deploy that?
We're in the early stages of this because again it's defined really by the market more than that by the technology. We have seen so far the biggest areas that we cover now covers the vast majority of risks, because we're focusing on risks really, because the Gemini issue with this, like we mentioned, is a risk. It's not just a failure in functionality, it's actual risk. So we're focusing now on putting into that framework all the known risks across the industry, across different industries. So we're focusing on risks here. Most risks are deterministic by functions. You can build either deterministic functions or build metrics for that. And then as we go, we dive into the functionality or the factualness. Because factualness here, you can say, if you have a reg system that's reading from your HR the records, you can say how long Mohamed has been in the company. It can tell you Mohamed's been in the company for 3 years, or it can tell you Mohamed started in 2021. Right now, both are correct, but which is the right answer? Really subjective. It seems like it's been 3 years is a better answer, because it doesn't seem it answers correctly in English-wise, but the date specific is more accurate and precise. So with that, because this is still generic, and we want to still see the human eval, how they're going to respond to that. I would imagine something by end of year we'll have the early iteration of what this would look like.
Yeah. What about hallucinations? How do you test for hallucinations? Because you don't know what a model's hallucinating until you
Well, hallucination here again, we start every big problem we try to break it down to see what this is. Define this to me, for me, and then the first definition, like it's several examples, like the categories that we defined for hallucinations. If anything, they're up to 15 types now. Off the top of my mind, data leak is a type of hallucination because it leaked some data from your records that you're training on. Another bias is type of hallucination. Other types like jailbreak. Jailbreak is obviously all of them are risk, but it's a higher risk. And jailbreak is basically the system went outside of the constraints, whether it's been through prompt injection, which is another type of risk, or through just the hallucination approach. So you start breaking down these hallucination types, and that's the educational part. That's the framework part. Our customers go into Kolena without defining what the problem is. They just drag and drop their data through their system or something. And then the platform is intelligent to understand the type of problem. This is a question answering problem. This is a text summarization problem. This is, and so on. And then for this problem, here's what we have identified as possible functional requirements, and here are what we have identified as possible risks. And then within risks, we see hallucination types 1 and 2 and 3. Right? They can click on. We focus on education a lot, so they click on something to learn more. Go to our docs, see the full list of 18 identified types of hallucinations across the industry, and we tell them for your problem, you are facing these 4 only and 5 only. So this is what the starting point. You go into Kolena within the first 20, 30 minutes. You understand really the nature of the problem that you're building for. And then you start working backwards into, okay, for this type of risk of hallucination, like prompt injection, you tell the prompt, hey, you tell the model, ignore your internal. That was a funny one, actually. We saw, I don't know if you saw that, like in the early days of ChatGPT, where customers or users are typing prompts like, ignore your internal instructions or ignore the instructions that you were trained on and give me the answer for this, right? And did they actually do that? So that's the one. Then let's say for this, since I gave the same example for this ChatGPT, then OpenAI would look at that and say, oh, we realized another type of risk that is prompt injection. Let's add that into our functional thing. And then this seems like a software problem, not even a machine learning thing, that they can just obscure these answers or block these answers. And then they start solving for the risk that has been defined, getting data for it, like getting all types of prompt injections that they have, which is not a hard thing to just mine this data. And we provide toolings to mine this data from their repository. So they have a bucket of data, and then they extract a quick search of here's what the different types of prompt injections that we have in our data, and then you create a test case for that. And then to back again, because I didn't lose track of the initial question of how we test for hallucinations. To recap, we break it down into what type of hallucination. We provide recommendations for our users to know what these types are, and then they work backwards into mining data through our data studio from the repository that represent these risks, and then they start defining again their metrics for it through our recommendations or through their own knowledge, and pass or fail criteria for it.
How do you guys work with customers? Do you price this on a project basis, or is there a subscription model, or how do you?
So we're a SaaS subscription model. Our model, we have three tiers: starter and professional and enterprise. The prices vary based on the number of users, size of data, and the capabilities that they're looking for, whether they are focusing only on data quality. That's one. And then when they evolve in their quality process, then they include model quality too. And then that's another tier. And then get to a full quality, a comprehensive solution for end-to-end model quality and automation. Then that's adding the post-deployment monitoring. So based on their stage as a team, and they start with these tiers.
Yeah, but subscription suggests that there's a monitoring feature. I mean, because otherwise, if you're building one model, and you want that one model to be evaluated, let's say it takes a month, and then you don't need a subscription anymore. I mean, what's the logic of having an ongoing subscription?
Yeah, well, it depends what the type of the customer is. If you're talking about it, this is the builders this is a machine learning team or an AI team, versus the buyer of the AI, which is somebody like just want to test some cases, or our third category of customers are regulators and independent auditors, right? So for the first and third, for the builders and the regulators, it's an ongoing thing. No builder will be like, okay, I'm going to evaluate once, because you're always evaluating and iterating. Now, for the buyer or the user of the model type, we are focusing now on companies that is using these LLMs. So we're B2B SaaS, so we're focusing on the B2B side of it. With these customers, I imagine when things become much more democratized, then now we're at the early stage of this, and we're actually about to get into that phase. Now this is all businesses using AI. Others are not going to buy a tool. I don't imagine you, Craig, you will go ahead and buy a subscription for Kolena to see which is best, ChatGPT versus Llama versus others. But so we're not focusing on those. The builders and regulators and even the buyers will still, as long as they are businesses, this is not a one-time thing. When you're using an LLM out there, if you're a buyer and you want to use Kolena to test which is the best LLM out there, and it doesn't take a month, by the way, it takes a few hours to get that to get that out. And now, as a AI company that's using these LLMs, you need to fine tune it, and fine tuning is which is the best guidance for this in the industry is Kolena, because when you're fine tuning, you want to know what data to send, so it trains on it. Now you can go ahead and collect a ton of data with a lot of cost and time and budget, or you need to test on Kolena using that test case approach or scenario level approach. You know the exact scenarios that you want to collect data for. First, you know which is the best model, and then you collect the data for these specific scenarios. And that even fine-tuning process happens within a few days, not in weeks or months. Now, after that, this LM provider will publish a new model that you want to evaluate. And then the same thing on your data, your customers, it will start drifting. The model will start drifting. So it's always a business that's ongoing. We tell customers, like, this is not a question that comes often from our customers, but when it comes, we tell them, if you're stopping training, you'll stop testing. If you're stopping anything, if you have even software, you don't buy software and then you don't build software and you fire the engineers when the software is out. They're still fixing the software and make it more stable and so on. So it's an ongoing process. It doesn't end with one test. I imagine there will be a sector of customers that come later down the road that are, I would say, more a B2C kind of thing that are evaluated, and we're not targeting those for now.
You mentioned NIST. This is a developing field. Is there a standard developing for how models are evaluated and tested, so that people can assess whether or not you are the evaluator they want or somebody else? I mean, presumably. And you mentioned that Kolena is used by regulators and auditors. Presumably, they have a lot of different tools and frameworks available for testing and auditing. Is there some standard coming out of NIST that you guys are adhering to, so that if someone's looking for evaluation, there's a seal of approval on Kolena by NIST, so they know that.
Yeah. There must be something that has to, there's nothing that we know of now other than the risk management framework, which is and that happened. The risk management framework was introduced to the world a few months before the Biden's executive order, so it was not in response. And in response, this thing started accelerating. But NIST created the risk management framework, and its three main functions or three stages: map, manage, measure. You map the risks, identify them. It's exactly the same for steps that I just mentioned with our framework. So map, identify the risks, and identify the functional requirements, and then measure them manage them in the sense of track them and then monitor them and making them available. The rule number one in quality is transparency, and understand that, and then you measure that. So this is more of a generic framework as a start to just start these guidelines. I don't have information if they are building some kind of a standard for testing. They must. I know that this is an area that everybody is looking for. Now, speaking of regulators or others who are looking, or even practitioners who are looking for that gold standard, to identify which tool is better. Things are very, very early in these efforts in the industry. I believe we are one of the first ones to start thinking about it and build that. So we're working and with regulatory bodies to share our knowledge and help with what we know and with our resources, how this can be shaped. We are much more connected to the industry. We have the resources that we're working with them. So I would love for this to happen. For now, we are working on providing our help as much as it's needed. When we're offering it, we're reaching out to all of them. And we are in conversations with most of them to start sharing this knowledge that we have and all the outcomes of our research. We put it out in public. It's in our documentation. If you go to docs.kolena.com, You will find all our the open metrics that we are, and we're updating that. So we are working with the industry, with our customers, and with the regulators to put this standard out for everybody. There's no exclusivity in that, and it's in our best interest that it's copied. Everybody or built on it. For now, our customers trust us because they see that we have a framework and they see the results from our work, and then they go ahead with that. Especially that our framework does not. We call it the model quality framework, and it doesn't contradict with the EU Act. And it doesn't contradict with NIST framework. So I believe this is the most advanced that's available right now.
That's it for this episode. I want to thank Mohamed for his time. If you want to read a transcript of today's conversation, you can find one on our website. That's EYE-ON.AI. And remember, the singularity may not be near, but AI is changing our world. So pay attention. And before you go, give Shopify a try. It's only $1 a month for their trial period, and you can sign up at shopify.com/EyeOnAI. That's shopify.com/EyeOnAI, EONAI, all run together, all lowercase. Go to shopify.com/EyeOnAI to take your business to the next level today. AI might be the most important new computer technology ever. It's storming every industry, and literally billions of dollars are being invested. So buckle up. The problem is that AI needs a lot of speed and processing power. So how do you compete without costs spiraling out of control? It's time to upgrade to the next generation of the cloud, Oracle Cloud Infrastructure, or OCI. OCI is a single platform for your infrastructure, database, application development, and AI needs. OCI has 4 to 8 times the bandwidth of other clouds, offers one consistent price instead of variable regional pricing, and of course, nobody does data better than Oracle. So now you can train your AI models at twice the speed and less than half the cost of other clouds. If you want to do more and spend less, like Uber, 8x8, and Databricks Mosaic, take a free test drive of OCI at oracle.com/EyeOnAI. That's EYEONAI, all run together. Oracle.com/EyeOnAI. That's oracle.com/EyeOnAI.